One talk standing between you and afternoon tea, and that is from our next presenter, who is a past EuroPython organizer, Django core developer working on the migrations part of Django, and today he's going to be telling us how to SSL all of the things. Please welcome Markus Holtermann.
Thanks, Chris. Thanks for the introduction. I'm Markus Holtermann. I'm a Django core developer for almost 2 years now. I started contributing in 2014, picked up every other migration bug that was out there, became a core developer in 2015 when the core team was too lazy to merge them themselves, and well, now I do that myself. Since April, I work for a German company called LaterPay. We do micropayment for online content providers and try to make both the selling and the buying part more easy and more convenient for you as users in the way that you, well, get access to the content before you necessarily actually give money, and then can experience the content before you actually pay, which is pretty cool. SSL all the things, and this is the topic of the talk. And being from Germany, we are kind of scared about all the things that happened to the with what Snowden revealed with what the NSA is doing, and there's a constant urge for more security, and this is mostly for German privacy laws or data and privacy laws, but also for generally European ones. And when you think about where you use the internet these days, you go to a cafe, for example, and take out your laptop and connect to Wi-Fi. Who tells you that this Wi-Fi provider is not doing evil things and wiretaps on your entire network communication? So you want to have security there. And also, there are some internet service providers out there that if you have unencrypted connections to a server, they inject HTML in the websites with advertisements, which is kind of nasty and not really what you want, especially when a website is otherwise ad-free. And this is bad user experience, also bad for security. And so this is something where security or SSL encryption or TLS encryption can help. This being a security talk, I need to give you a short disclaimer. I'm not a cryptographer. I don't know anything about the underlying mathematics of these things, but that's OK. All the examples I give here are either to the best, at least of my knowledge, or if I was unsure, I talk to skilled people I trust about their idea or their thoughts on those topics. And this still means there can be errors. If you're keen on, or if you know something about the topic and you spot errors, please talk to me before I put up the slides so I can correct those and not publish mistakes there. This talk will also not cover everything about SSL, TLS that's out there, because that's too much and would probably be enough for an entire conference. SSL 2 and 3 are broken. Do not use that. TLS 1.0, 1.1 are, well, not necessarily outdated, but are discouraged and superseded by 1.2. If you don't have to use them for fallback reasons, probably just go with TLS 1.2. And if that's not secure enough for you, well, you can go into the future with Google with an algorithm called New Hope. They come up with a couple of weeks ago. I'm not sure what supports that yet, but it's post-quantum computer cryptography. OK, so much about that. SSL, TLS are two words or two abbreviations standing for Secure Socket Layer and Transport Layer Security. And they are both cryptographic protocols that are used for communication, most notably networks. And either one provides 2 out of 3 things of information security. The first one being confidentiality, which is achieved through encryption of the data. That means nobody who has access to the data is actually able to figure out what's being transmitted, except for this pile of garbage. Then there's integrity in there, which ensures that nobody can provide different data than what should be in there. Nobody can change data, the data that was transmitted. The third part of information security is availability, which is unfortunately not part of the cryptographic protocols. This you can achieve through load balancing your site, for example. I'm pretty sure all of you have at least come across Let's Encrypt, even if it's only I've heard about it. And what is it, and how does it relate to this talk? And the entire SSL thing that I mentioned before, how do you actually do that, and how does it even work? And this is what I want to explain to you in this talk, and then how to use and how to get certificates and all those things. Let's start with how SSL actually works. Not the cryptographic part, but on the bit higher level from a user's perspective. Let's take a browser. Browsers have these things called trust stores. This is a collection of certificates that the browser vendors think are secure or are from so-called certificate authorities, and assemble them and deliver them with your browser. And these certificates or root certificate authorities, they have intermediate certificates that they signed. And by signing, that means that when your browser trusts the root certificates, everything that is signed by a root certificate, your browser trusts as well. And in return, when something is signed by an intermediate certificate, because your browser trusts the intermediate certificate, it trusts the signed certificates, or leaf certificates are these down at the bottom are called. Now, certificate authorities don't necessarily need to sign only their own intermediate certificates. They can also sign others, which you can see on the right side here. Now, root CA3 is not part of the trust store, as you can see in the picture. But because the root certificate 2, or the root CA2 that you can see here, is part of the trust store, the intermediate certificate 3 is trusted. And if root CA3 has access to that intermediate certificate and has the appropriate permissions to do things with that certificate, it can actually provide valid certificates for you as a user, for example. And this is essentially where Let's Encrypt comes into play. Let's Encrypt is a root certificate authority which is currently not in trust stores of modern browsers. Firefox 50 is going to include Let's Encrypt, but that's a couple of weeks from now. Let's Encrypt controls their intermediate certificates, meaning they can sign other certificates with that one, and because there's another root CA that trusts that intermediate certificate, Let's Encrypt can provide you with certificates that are trusted by your browsers. And this is why Let's Encrypt is being used on more than 5 million websites. Let's Encrypt also provides a fairly easy API, REST API, that you can use to then automate a process to receive a certificate for a domain that is under your control. And that process is called ACME. That means Automatic Certificate Management Environment. And it's a fairly simple JSON API with some crypto magic, and does not necessarily, well, it's not really complicated. It just has 4 steps from the first time you use it to here's a valid certificate. In order to use that, you need to have an account key for Let's Encrypt. You need to have a certificate key, which is something that's the secret part for the SSL connections to your servers on your side. And a certificate signing requests, which is an intent that you send Let's Encrypt to, can I please have a certificate for these domains? Now, when you look at the process, it's a fair bit of diagram here, but you can see the 4 parts in here. The first thing is that you authenticate or register your account with your account key. Having done that, you send the signing request over to Let's Encrypt. They take that apart, look at the domains they want or you want to get certificates for, and they provide you with a bunch of challenges or with a bunch of files you're supposed to write in a particular domain on your server. When you've done that, you tell them, okay, I wrote all the challenges down, and they are going to request all the challenges. These are a bunch of HTTP requests coming in. They check for the content of these files, matching what is supposed to be there, and if everything is fine, you can request the certificate. Now that you have the certificate, how do you actually, or now that we understand the process here, how do you actually get those certificates? And there's an official Let's Encrypt client out there that does all the magic. Literally, it rewrites your Apache config if you wanted to. As far as I understand, they even are working on an Nginx integration. If that's the right way forward, I'm personally not. I personally don't think so. I gave a talk at last PyCon Australia about configuration management. If you want to go and look at that for more details, well, I don't think it's the right choice. There's scripts out there called there's a script out there called ACME Tiny. Has about 200 lines. If you want to look into how the process this API actually works, read that. I encourage you to actually read that because it's really well written. There's a bunch of other tools, for example, Let's Encrypt AWS by Alex Gaynor, which, as the name suggests, is for AWS integration. And there's a tool called rproxy by Amber Brown, which sets up a proxy with Let's Encrypt integration. And you write a couple of config lines, and it does all the magic for you. In order to get these challenges working, you need a bit of a web server configuration. This is what you work on, what it looks like for Nginx. This is the part of the location where Let's Encrypt is looking for, and then some random file underneath. This is the Let's Encrypt or ACME Tiny script that we use at djangoproject.com and I use for my own sites. It's a slight variation of the ACME Tiny script, as in I added a bit of support for systemd and a couple of other tiny things. You provide your account key, the signing request, you tell it where to put the challenges and where to put the certificate, and yeah, you're pretty much done. Now that we have these certificates, how do we actually use it? And being at PyCon, let's talk about doing that in Python. Let's start with the client side. That's it to write an SSL client in Python that connects to an SSL server, writes something, and receives something. It does validation on the host name. It does all the things you should do by just letting Python deal with that. You create a socket, you create an SSL default context, and with the SSL purpose server auth, you tell Python, this is a client authenticating against a server. You can drop TLS version 1 and version 1.1 if you want to. TLS SSL 2 and 3 are already either unsupported, but depending on which OpenSSL version you use, or not included by default. And then you wrap the socket with this SSL context, connect to the host, and then do network communication as you would do it in Python. The server side does not necessarily look much more complicated, to be honest. Let's look at this. Fair enough, there's a bit more code here, but most of that is something you would otherwise define in your Nginx or Apache web server when you set up SSL there. The important part here is, again, the purpose. So the server authenticates against the client, and you need to load a certificate. There's a bit of a separate syntax you can use as well. You can either put the SSL key or the TLS key in the in one file together with a certificate and the intermediate certificates, or you can have the key in one file and certificates in another one. Then you potentially will disable TLS or some TLS versions. And what you want to make sure is that you set an appropriate cipher string. That's a OpenSSL cipher string. I'm not going to go into the details of how that is composed and how to figure out what you put in there. There's a website called CipherList. This is a string they currently recommend. And this is one of the things. I have no idea how to do that. Let's look it up where people that know how to do it tell you how to do that. Again, you have the context. You have your SSL. You have your socket. Let's wrap the socket with the account context and do communication. And that's all. Now, what I didn't cover, but at least want to mention, depending on the context where you use SSL, that might be from Python itself, that might be in your web server, that might be in other projects. You should have a way and a process for certificate revocation. Certificate revocation you do then when you potentially compromise the key, regarding the belonging SSL key, because otherwise, in that case, the certificate could otherwise be used by the owner of the key, and you don't want that to happen. You also might want to have, when you use Let's Encrypt, you might want to have an idea what you do when you have a compromised account key. Let's Encrypt has an API to do either process as well. And these are, again, only 1 or 2 HTTP requests against their API. In the context of HTTP, there are 2 things out called HSTS and HPKP, which stand for HTTP strict transport security and HTTP public key pinning. The latter, probably being not that publicly known, is also not necessarily the thing you need to worry about. It's probably more a thing more for like huge enterprises that are under constant attack. HSTS is something you might want to consider for your own domains. It essentially tells browsers to, once they have this HSTS signature received once, to never ever try to access that site via HTTP again, ever, for the next, the standard says, I think, 1 year. That means if once you've visited this site via HTTPS, nobody can force you to visit it via HTTP, which means websites like Facebook, for example, nobody can downgrade you to an insecure connection because your browser is never ever going to try to access an insecure version of this website. But both of them have a problem, as you can probably derive from when your browser is not trying to access this site on an insecure version ever again. What happens if you want to turn off SSL? Well, you can't really. The only thing you can do is to disable HSTS for the time of the length of these HSTS sessions, and then go to when this time is over, turn off SSL, because at that point no browser actually has this indicator anymore. If you set HSTS now on your web shop and your users are using that or accepting that, and you turn it off tomorrow, all those people accessing that in the meantime won't be able to access your website anymore. Just be sure about what you do there. As mentioned, or as shown in the process of here's how you use that in Python, you can, of course, use the certificates from Let's Encrypt for other services. They don't need to be used on HTTP, as long as you have a way to get that certificate. Things that could go wrong. And it's being cryptography, there's a lot of that. HSTS, HPKP, as mentioned, if you do it wrong or if you disable it too early, then you lose customers. You potentially be able to leak keys. There was a talk right before by Noah Kantovic that you might want to watch on YouTube when it comes out and how to distribute keys. People claim that the resource usage for HTTPS or SSL in general increases. Yes, of course it does, but the majority of servers won't probably have any, or it probably won't implicate any of your daily business, because at least if you run mostly modern servers, they have CPU internal or hardware cryptography implemented in some way that helps speed things up. This is a list of a couple of sources that I recommend to look into. The first one is the Cypher list. SSL Labs is probably the standard testing tool for SSL if you want to see what you did wrong or how you compete against others. Hinek has generally a couple of good talks on security, SSL, and others. This is the ACME tiny tool. No, this is the ACME standard. The post-quantum algorithm, and a link to the snippets I showed earlier. Thank you.
Okay, by now I hope you know the deal. If you have a question, put your hand up and I will run a microphone to you. Don't start talking until you have the microphone. Are there any questions? Yes.
Hey Markus, thank you very much for your talk. I just wanted to ask about, so generally now, I think most people consider it best practice to sort of redirect everyone to SSL. Firstly, whether or not you support that, but then secondly, what sort of strategies you've used to handle older browsers that don't support the newer Cypher suites or TLS 1.2?
Figure out the minimum browser support you have. Use SSL Labs to figure out what you need to support. So go with the Cypher suite and then figure out what you're missing and append that to the end in a way that is slightly optimized, and see that you support the browsers you need, but only those you need.
Any other questions? Excellent.
Great talk. Further to that one, the way I think the way it fails now, if you say I'm not going to support older browsers, they just get a white screen. They get nothing. Like they don't. Is there a way to gracefully say, I'm not going to support you, but you need to upgrade your browser?
I'm not sure. I think it also depends on the browsers how they handle cryptographic connections that they are not able to deal with. Generally, what you want to define is in web servers is the preferred server ciphers, which means that a browser cannot send a weaker cryptographic algorithm. If you, I'm not sure if there's a way to actually tell browsers or tell your web server if this is browser handling not handling these ciphers, then redirect them there. If there's a way for that, please tell me so I can read it out again.
We have a question down here. I'll just pass the microphone.
Thank you for the talk. Certificate pinning and client libraries. Are you aware of how we can do this so that we can make our apps connecting to our web servers more secure?
I haven't looked into that, to be honest. Certificate pinning is a bit of a problem with Let's Encrypt. If you look into the, if you want to pin on the serial number of the certificate, because Let's Encrypt certificates are only valid for 90 days, which is fine because the automated process normally runs every 30 days, 60 days, and then renews this, or gets you a new certificate. If you manage to ship out versions or updates in the meantime to your app or kind of force shipping of those updates, you could do that, but otherwise certificate pinning with Let's Encrypt is not really suitable right now.
No further questions? Yeah, take my time to get to the front of the room here. I have here one of our fantastic sailing tram coffee cups for you as a token of our thanks for giving this talk.
Thank you.
Everybody, please thank Markus.